So we're solving this equation for L. So you guys remember last chapter we had an equation like something like that. How did we solve this for X?
Divided by 5.
We divided by 5, right? And then we did that divided by 5, 20 by 5 is 4. Okay, how would I solve this equation for L? What it means is I want to get L by itself, and I'm going to use the same tricks as this. The only difference is there's no numbers. So what's happening between the L and the W? Multiply. So how do I get rid of, if I'm solving for L, how do I get rid of the W? Divide by W. Because what's times W divided by W? That's gone. Okay, just like over here, I divide by 5, right? To get rid of the 5. Over here, I'm dividing by W. W is some number, I don't know what it is right now, but I'm dividing by W. But if I do it on this side, I've got to do it on the other side. We don't know yet. Depends on what the problem is. So the length in a rectangle is equal to the area divided by the width. Okay? So this is like manipulating formulas to change them to something you want. So maybe you know what the area is and you know what the width is and you want to find the length. This is the formula you would use. Okay, this is kind of a basic formula, so I'm not sure you would need to do that, but this is kind of warm us up here. What's another formula? How about perimeter of a rectangle? You guys know what the formula for that is? This is probably on the assignment today. What's perimeter mean? Right, it's like how far around it is it? Perimeter, right. To find the perimeter for a rectangle, you need 2 of these plus 2 of those. 2 lengths plus 2 widths equals a perimeter. Okay, well, what if I said solve for, let's say, W this time? Okay, let me throw in a problem that looks kind of like this. Kind of like that one. You guys see how these are similar? Here, I'll make this a W so it's less.
You're making basic math so much more complicated.
This is not basic math. We're stepping it up a notch. Okay, Brian, just because it's not easy doesn't mean we can't do it though. All right, so we're solving for W. How would I solve this for W? No? Well, you would. Normally you want to subtract first, right? Get rid of the add or subtract number value first. So you'd subtract 42, 58. Okay, then what would we do?
Subtract 2 from both sides. Divide.
Divide by 2. Okay, and then that would be our answer, right? Okay, we're going to do the same thing for this, but now we're solving for W. So what should I do first?
Subtract.
Okay, you're right. How do I get rid of 2L? Kind of like when we got rid of, when we had X's on both sides, you know how we subtracted it from both sides? You can subtract 2L from both sides. That'll go away. So what's P minus 2L?
P minus 2L.
Yeah, doesn't simplify, right? Don't know what it is. But that would be equal to 2W. Let me get rid of this. Now what would we do? Divide by 2. Well, where do I put the divide by 2? The whole thing, yeah, is divided by 2. So we get W equals, and then that's basically the answer. Now, there's kind of an important note on this. Sometimes, okay, guys, do we need to have assigned seats? I'm starting to think yes. I don't know if we can handle it. You can leave it like this, and I'm not going to count it wrong. But sometimes, in certain situations, you might want to break it apart. Dividing by 2 means basically both of these terms are divided by 2. Kind of like the distributive property. You know how when you multiply both of these things by 2, like distribute? This is divide both of these things by 2. So this is also equal to, okay, did you guys see what I did there? It's like P divided by 2 and minus 2L divided by 2. Okay, you can leave it, you can stop right here. I'm not going to count it wrong. Later on there is something we're going to do where we'll need to split it up though. Does this make sense where I got this from? Okay, this one over here when I split it up, that does simplify a little bit. 2 divided by 2 is 1, 1L is L. This one doesn't really simplify. I'll probably just be stopping right here. Sometimes the book does both, and I can never tell which one they're going to do, but we'll probably just go to that. All right. Here we go. Number 1. You know what? I put 1 through 20. One of these is really hard, and I'm not sure I want to do it. It's number 17 though, so it is an odd. For some reason I threw a hard one in there on number 17. I'm thinking about replacing it with like 22 or something. That's okay. It's a hard one, but it's an odd, so it'll be okay. 18 looks difficult, but it's not as difficult as 17. Number 1, A equals bx. We're solving for x. All right. Does anybody want to volunteer? Jesse, what do you think we should do?
Divide by b, both sides.
Divide by b. So over here, the b's are going to go away. And we get x equals a over b. That's kind of like my first example, wasn't it?
Not really.
I divided by one letter, just like my first example. Do you understand it better now? That's why it looks weird. See, I just divided by W. Same thing. Okay, number 3, x over r equals r. I did not do an example like this. And we're solving for x again. Sophia? Times by r. Yeah. So to get rid of a divided value, we have to multiply. What is r times r?
R squared.
R squared. That's what squared means, something times itself. How do you get 2r? What would give you 2r? R plus r. R times 2 also, yes. R plus r is 2r. Okay, number 5. Y equals mx plus b. If you're in 9th grade, you should recognize that. 8th grade, probably not. You guys remember this, 9th graders?
Yeah.
You guys have seen it?
It's a multi-step equation.
Slope intercept. Oh, maybe that is in the 7th grade book.
Yeah, it is.
It is. I forgot. It's been a while since I've seen it. Yeah, it's slope intercept form. You don't really have to know that right now. That's something we'll do later on. But we're supposed to solve for b. Lauren, how do we get b by itself? No, b we want to stay still. So we don't want to minus the b. So how do I get rid of this guy? Well, it's kind of like kind of like this one, I guess. Best I can do. Well, what do we do if we're solving this? No? If you have x's on both sides, what do we do? We would subtract 2x to get rid of it on one side. And then those would mix. Okay, so this we want to stay still. This we want to go away. So minus mx. Does y minus mx mix? Nope. No, that sounded almost like a pump there. Y minus mx equals b. So that's it. Kind of wrote it backwards. Okay. Number 7, I equals PRT. I'm pretty sure you guys don't know this one. Oh, somebody did. Principal times rate times time. Did you guys do that last year?
Yeah.
Okay, I was wrong. I don't remember what's in these books. We are doing this a little bit this year, or this chapter actually. Interest, we're not talking about it today, but we're supposed to solve for t. Manny, how can we get t by itself, do you think?
Would we subtract PR?
Okay, when the letters are right next to each other, what does that mean?
It's multiplication.
Multiply. So how do I get rid of multiplied values? Divide. And you can do this all at once, by the way. You can divide by r, divide by p, or you can just divide by pr. Just all at once. Divide by pr. So t equals... Yeah.
Can we go over 4?
Let's see. Number 4 is a lot like the one we just did, number 7. So it's starting with multiplication. So your step is gonna be division. On 4. After you divide, one of your letters should cancel out. Number 8, P equals A plus B plus C.
9.
Is that 8?
9.
D, number 8 was more interesting. D equals RT. You guys remember that or recognize that formula?
Distance equals rate times time.
Distance equals rate times time. 4t. Okay, where are we at? Brian, what do we do here?
Would we do minus R?
Not minus, because what's happening right here?
Divide.
Yeah, it's multiplied, so we need to divide by R.
Oh, shoot.
It's just like number 1. So what does this tell us? It tells us that time is equal to distance divided by speed, divided by rate. Number 11, P equals 3S. The odds in this section look a little bit easier than the evens. P equals 3S. The next section, I think the odds might be harder. All right. AJ, what's our step for this one? We're solving for S. Divide by
3.
3. That's quick. Okay, so divide by 3. Those go away. We get S equals P over 3. I do not know what that stands for. That might just be made up. Number 13. These are made up. P over 6R. Okay, we're in the B section. That means it's getting more difficult. We're solving for P. Move this guy out of here. All right, Bo, any ideas? How do we get P by itself here?
No clue.
Okay, what's happening between the P and the 6R in
Division,
division? How do we get rid of division?
multiply.
Multiplication.
Where did you get multiply? The 6 odd?
All of it. All this stuff that's divided is going to need to be multiplied. So here's what happens. How do I write 6R in as a fraction?
Over 1.
Over 1. What's happening is when I multiply the left side by 6R in, that goes away, which is what we want, right? On the right side, when I multiply by 6R in, really I'm just multiplying the top by 6R in.
You can do the cross.
Right.
Or just call it
Cross cancel.
Yeah.
So yeah, the 6 and the 9 will reduce. Remember the multiplying fractions trick. If you divide by 3, this becomes a 2 and a 3. So what do I have over here? P equals 7 times 2, 14 Rn. Over, what's on the bottom? 3nx. Okay, I wasn't paying very close attention. Those n's also could have reduced, just so I can reduce them still though. Those n's reduce. Multiplied values that are being divided, those can cancel out. So it's just 14r over 3x. All right, what else we got? Actually, before we go on, let me talk about one more thing here. Okay, I'm making this one up, but I need to make a point because it's going to come up on number 18. Let's solve this one for x. So, how would I solve anybody? How would I solve this for x? Okay, you would have to divide by 3y. Okay, here's the thing though. Dividing by 3, how do I divide this by 3y?
multiplied by 1 over 3y.
Right. What's 3y as a fraction?
3y over 1.
3y over 1. How do I divide a fraction?
Multiplied by the reciprocal.
You flip it, make the reciprocal, and multiply. So when you divide by 3y, what you're really doing is multiplying the denominator by 3y. Okay, this is going to happen on number 18, maybe a couple others too. So really, it just goes on the bottom. So the 3y just goes on the bottom. So last problem, we multiplied by 6rn, and it went on the top of the fraction. And then sometimes if you have to divide, it'll just end up going on the bottom. Multiply it to the bottom. Let me see if there's an odd like that. No, not really. 16 I guess just 18. Maybe I'll help you guys with 18. 18's weird in a couple different ways. Okay, 15. They're back to y equals mx plus b. But this time they want to solve for x. Kenton, how could we solve this for x? Okay, how would we solve this for x? You wouldn't divide by 2 first. Minus 5 first. Then what would you do? Divide by 2. Okay, so what do we need to do to solve this for x? Minus b. And then divide by m. The x is staying still. We don't want to. We want to get rid of the m like that, but not the x. So don't do anything with x. And then m over there. So x equals y minus b. Okay, 17. I told you guys this was the hard one. I'm not sure why they put this one in here, but that's okay. Maybe some of you will get something from this. I don't suppose you guys recognize this formula. Well, actually you might. Yeah. You guys recognize that formula? It's called the slope formula. If you have a couple points on the graph, it helps you find the slope between those points. Probably have seen it, but I'm not 100% sure. Okay, we're solving for what? X1? Okay, I'm just gonna have to do this one, but have you guys seen this notation before? Why does this one say x with the little 2 and x with the little 1? What, have you guys seen that?
Separate terms?
Yeah, it's referring to 2 different x values. It's basically 2 different variables. It's like, you guys know, like points on a graph look something like this, right? It's like x1 might refer to this 2 and x2 might refer to the 5. Okay, so it's basically 2 totally different x's, 2 different variables. So you got to treat them like they're different, just like you treat x's and y's like they're different. You cannot subtract those 2. They're different. Okay. It's a little bit beyond us, but that's okay. I'm going to do it anyway. So what I'm going to do first is get this off the denominator. I'm going to multiply both sides by x2 minus x1. Because what happens on the right when I multiply by these values, they just go away. That gets x2 minus x1 off the denominator, which is what we want. Don't stress out about this one. So I have m times x2 minus x1, what? Anybody want to guess? I'm trying to get this guy by itself. Anybody want to guess what I might do next? Still kind of hard. That's a good guess, but distributive property kind of puts stuff together. In this case, it won't help.
Would you add 1 or y?
No. I
Divide by y.
don't want to move this stuff here.
Divide by y. I mean, divide
Yeah.
by n.
We can clean this up. Since the whole left side is multiplied by m, we could divide by m. That'll clean it up a little bit. So that just goes away. Now, since that's all that's left, the parentheses isn't really necessary. Oops, I forgot the end. But we're getting close. How do I get rid of x2? Yeah, the technical way to read this, by the way, is x sub 2, x sub 1.
Couldn't you subtract x sub 2 by x sub 1?
No, that we talked about they're different variables, even though they look alike. Okay, these don't really mix. Almost done. What am I missing? Negative. I mean, need to multiply everything by -1, basically. So this would become a positive x2. I'll put it, and I'm going to put it in front. Order of addition doesn't matter. And this will become a minus in front of that thing. I don't know why they put that one in there. That's kind of naughty of them. I'm not even sure I would put that for a bonus question. But that's it, we're done. Once you get x1 equals, that's it. Okay, 19, 18, 20, they're not as hard as that one. All right, 19, back to the normal stuff. S equals 2 pi r h. This was something you'll see next, you guys will see this one next year. This is the surface area for a cylinder. For H. Alright. Okay, lots of stuff. Like, this looks complicated, but it's really a two-step problem. We're supposed to solve for H. Like, all of this is just one term. So this is really just a two-term thing over here. James, what do you think?
Subtract the 2 pi r squared.
Right. Let me change this into a problem that we're used to. Okay, this is kind of a simplified version of this. How would we solve? We would subtract the 6 and we divide the 2, right? So he said subtract 2 pi r squared. It's a big mess, but we don't have to really worry about it. We just do the same steps. Get that guy out of the way. All right, so these don't mix. S minus 2 pi r squared equals, that's gone, 2 pi r h. And now what, James?
We divide by 2 pi r.
Right. 2 pi r, that's all just multiplied stuff. So to get rid of it, we're going to divide 2 pi r. Divide 2 pi r, and that's basically the answer. H equals S minus Okay, I need to make an important note right here. We're almost done, but some people, this is a problem with my Algebra 2 students even. They would try to reduce this, like cancel the 2's and the pi's and the r's out. Does anybody know why you can't cancel those out?
It's the whole thing, it's all of it, not just a part of it.
Right. This is not just this divided by this, it's dividing this and this. So unless you split it up, you cannot reduce it. Okay, if it was just one term, like if we split it up, Now this does reduce. But you can't just get rid of it over here because it's also dividing the s. So you could just leave it like that. You guys don't have to do this extra stuff. It's just kind of an important concept for later. R squared divided by r is r. So all that would just turn into an r. This version is a little simpler, but you can stop right there. It's fine. Okay, number 18. Let's go back and look at that one because that's looks confusing. P1, V1, T1. I'm guessing it has something to do with pressure, volume, and time, but I'm not sure what this formula references. Maybe it's a looks kind of like physics to me, but I never took physics, so I'm not sure. Okay, we're supposed to solve for P2. And are you totally lost? It was easier at the beginning.
How does that equation make sense? Because it's everything.
Okay, remember P1 and P2 are not the same variable. They represent different.
Oh, I thought those were commas or something.
Okay. Yeah, so these are like 6 different variables. Okay, so there's a couple things we can do. P2 is what we're trying to get by itself. It doesn't really matter. You could try to get rid of the V2 first or the T2 first. Let's get rid of the T2. How can I get rid of T2? Multiply. Now, you guys remember how I said, how are we going to multiply this by T2? Yeah, the top basically gets it. If you multiply by T2, you're multiplying by T2 over 1. And basically it's just going to go on top. So, now does the order of multiplication matter? No. So, you can kind of put T2 wherever, over there. So we still have P2, V2. Okay, one more step. Divide V2. Okay, but again, how do we divide this by V2?
We should divide it.
Okay, dividing by V2 is the same thing as multiplying by 1 over V2. So when you divide a value, if there's a fraction over here, it just basically goes on the bottom. So we have P1, V1, T2 over T1, V2. Okay, so we multiplied, let me go back to the beginning. We multiplied by T2, it basically went to the top over here, and we divided by V2, and that made it go to the bottom. And that's all that happened. This one went here, this one went here. Okay, that's probably the hardest even. Not that there aren't still some challenges left, but. All right, let's give it a shot.